Yesterday, after the quiz, I had you read page 12, which was a reading all about intrusive and extrusive igneous rocks. Then I had you fill out just this top half, which told you, it was basically the notes for this chapter. So I am going to ask you what you wrote and make sure you get this filled in. This is the notes for intrusive and extrusive rocks. So you're going to want your notes to be perfect. So if you didn't have some of the things we're going to add to these, make sure you add them. Or if you had something completely incorrect, make sure you change them because these are your notes. All right, let's get started. Where do intrusive rocks form? Where in Earth's crust? Below Earth's crust. So where could we say they form? That seems kind of complicated, below Earth's crust. Let's simplify that. Where do igneous rocks form? Or intrusive igneous rocks form? Under the ground? Okay, you're all right, but let's keep it simple. They form inside Earth, which again means below Earth's surface. Yep, that's a part of the inside. I like the word inside Earth because these are intrusive. Inside. It just keep it simple. What does intrusive mean? It means it forms inside Earth's surface. Don't overthink it. So it's inside the Earth. Because they're inside the Earth when they form, how do they cool? Cool slowly. Okay, cool. They cool slowly because the layers that are above them act like a blanket, keeping them warm as long as possible. Because they cool slowly, what physical properties do they tend to have? Large crystals. And they gave a very common example. What they give? They did not. Granite. Really? Not sure what you read. No, doesn't. For examples? Yeah. It did not. So change that. I'm not sure where you got that common mistake from. Okay, so that's cool. All right. So Minecraft, you find them in a cave. You must have got it from the reading because on the quiz. The quiz says almost all diamonds are mined from igneous rocks. So it is true, but the most common and the one from the reading I asked you to read for this was granite. Okay. This is what you need to know about intrusive igneous rocks. If your answers say anything different, make sure you at least have these underlined, bolded, starred, or something. You need to know that intrusive form inside Earth. Because they're inside, that means they cool slow. And because they cool slow, it gives the crystals a long time to grow. So you're going to end up with very large crystals. And one of the most common examples of this is granite. Now, oh no, I'm not quite ready to show you this. And by large crystals, it means ones you can see without trying. It doesn't mean you can see them from like the back of the room, but it means you can pick up a rock and you're like, oh yeah, that's a bunch of crystals. For example, here is a piece of granite, and we're going to get into more details of this next. This is a piece of granite. All of these little pieces that you're seeing, all these black spots, all the white spots, I don't know how much it shows up on the camera there, but all the pink spots, those are all different crystals, and they're so large. You can see them. Some of them are the size of my pinky, if not a little smaller, but you don't even have to squint to see them. You can see them. There's no doubt these are crystals. This is different than extrusive. What are our choices for extrusive? or I'm sorry, what is the environment of formation for extrusive? On Earth's surface. On the exterior, like exterior, extrusive, they exit Earth. These are all the ways I remember extrusive. Because they cool, or because they form on the Earth's surface, how do they cool? Cool fast or rapidly. It's cold on the Earth's surface. Even 100 degrees is a lot colder than molten lava. Hopefully you've all seen pictures of when lava hits water. If you haven't, maybe I'll pull up a video of it tomorrow to see what it looks like in Hawaii when the volcano starts erupting. That lava starts to cool almost immediately. Because it cools fast, what are the physical properties? What does it mean to be glassy? Too complicated for these notes. Now, small crystals. In fact, this was not included, but I want you to add it. So small or no crystals. So make sure you have that. So if you had something like glassy, you're correct. But in this point, you probably don't know what it means for a rock to be glassy. Because it, believe it or not, does not mean it. It does say it in the lab. So if you got to, but what I need you to understand, and we're going to talk about it in a little bit, glassy igneous rocks do not look like glass. That is something we have to talk about. What were some of the examples they gave in their reading? Didn't it give another one too? I think they did also say pumice. Yep, pumice. Not hummus. We're not talking about the dip you might put on your vegetables. It's pumice. All right, we're going to skip the chart for right now. And we're going to skip the follow-up questions for right now. And we are going to head to page 16. I'd also like you to take out your reference table and open it up to page A6. So packet page 16, ESRT page 6. Those of you who had lab yesterday or already today with Mr. Miga, you have started looking at the reference table for igneous rocks. And I'm guessing, since you had never seen it before, it was probably confusing. In fact, for my lab today, I just told them to skip it for the beginning of today. Later on today, when everybody's already had this lesson, we're going to get started on this 12th period today. So what I have for you on page 16, and you're going to want to turn your paper so that the chart looks correct. So we're turning our paper sideways on our packet. The reference table is already the right way. So what you'll see on page 16 of your packet is you'll see this reference table. The way I printed it, it might be a little blurry for you. So that's why I'd like you to have your regular reference table to page 6 open as well if you need it. So there's so much going on this reference table. What I really wanted to do in our packet is take notes right on our reference table. There's no room, so what I did is I just made it smaller and added room to write here. So this reference table, again, is a dichotomous key, organized in a much different way. So the first thing, so on the mineral reference table, they were sorted by metallic or non-metallic. Take a look at these rocks. What's the first thing that they get sorted into groups based on? So everybody look at the reference table. What is the first thing that they get separated into groups by? They get separated into intrusive rocks and extrusive rocks. So what I mean here, and let me show you. So first of all, here are the names of the rocks. So all of these are the igneous rocks we're going to use. And in there, you'll see some of the examples we talked about in the reading. There's pumice, there's obsidian, and granite are all listed there. So these are the names of the rocks. And the first thing, like you said, they get separated by are whether, if they're on the top half of the chart here, they're extrusive. If they're on the bottom of the chart here, they're intrusive. So what we're going to do is in this top bubble, so top left bubble, we're going to again define what it means to be extrusive. That's all that's going to go in the box. So you know how big to write. We're on page 16, Haley. So you'll see that that bubble is pointing to the word extrusive. And we already defined yesterday and this morning already, extrusive means they cool quickly on the Earth's surface. So the extrusive rocks, can you guys look at your chart and tell me what are the names of all the extrusive rocks? Obsidian, pumice. Which letter does it begin with? V, vesicular rhyolite. Rhyolite. Vesicular. Vesicular andesite. Andesite. Yep. Basaltic glass. Want me to read the rest of them? Scoria, vesicular basalt, and basalt. Yeah, so these words are weird. I never expect you to be able to spell them off the top of your head or pronounce most of them for the most part. As long as you can give me the idea of what you're talking about, it's good, just like Tyler just did there. What about this one here, diabase? What do you think's going on with that one? I know you can't see it on mine. Take a look at your own. What's going on with diabase? Okay, it wants to be different. It's in the middle there. So sometimes diabase will be intrusive, sometimes it will be extrusive. But as long as you can see there where Tyler got his list from, any that line up with the box for extrusive are going to be the extrusive rocks. On the same note there, let's do the one right below that. Intrusive. And there's a word there, it's called plutonic. I should have actually talked about what it is for extrusive too. I'll let you write this. Intrusive, which is plutonic, they cool slowly beneath Earth's surface. So plutonic is not something you have to memorize. It's just another word for intrusive. Has to do with like the Roman god Pluto, which had to do with something about the Earth. I don't know, not my department. But if they're, just know that if they say plutonic, they just mean intrusive. I forgot to mention, what's the other name for extrusive? Take a look at your reference table. Volcanic. Now that's helpful, right? Because when you picture a volcano, what's it doing? Yeah, okay, let's get a little more dramatic. What did you say it's doing? Exploding. When a volcano is exploding and spitting its lava everywhere, it's on the surface, right? It's exiting the Earth. So that should help you if you forget for some reason what extrusive or intrusive means. They gave you that hint. That extrusive means volcanoes. So volcanoes are on the exiting the Earth. Plutonic, I don't think helps at all unless you know your Greek gods or Roman gods. For most of us, that means nothing. Yeah, but plutonic, I just was reading. It was in the lab. Let's see what the lab had to do. Yeah,
I read Percy Jackson.
What?
I read Percy Jackson.
I don't even know what that means.
You don't know Percy Jackson?
No,
Really?
no, I'm not a real. So it says the term Plutonic comes from the name Pluto, the Roman god of the underworld. There you go. So it's the god of the underworld. So these are the ones that are under. There we go. So at least it makes some sense, but you have to know who Pluto is. I didn't think that was him. I thought I was with you with Hades.
Yeah, no, because they're the same person.
Oh, they are.
Because Pluto is the Roman version.
Oh.
Hades is Greek.
Oh,
Yeah.
well, you're pretty informative.
I read Percy Jackson.
Again, I don't know what that means.
Really?
You're going right over my head.
No way.
I have no idea what you're talking about.
Sixth grade.
A lizard boy that does stuff. That sounds awful. That sounds like you shouldn't have read that in sixth grade. Don't listen to him. He doesn't know what he's talking about.
Yeah.
So I clearly didn't have your sixth grade teacher and didn't read that. Yeah, no, it's a possibility. My daughter's in seventh grade and her fifth grade teacher was my fifth grade teacher. And now her art teacher was my art teacher. And her chemistry teacher is going to be my chemistry teacher. There's a few left. The chemistry teacher, I'll give him, he's only a few years older than me. He was like 22 when I had him. So, and I was 18 when I had him. So he's only like 6 years, and he's got a daughter in my daughter's grade. So he's not going anywhere for a while. The art teacher's pretty old, but she's like cool. The fifth grade teacher, I had her first year, and my daughter had her last year. So interesting. Anyway, moving on. Sorry, Caden. Let's move on. Top middle one. It's pointing to the crystal size. And we already established, and we said this once already, so top middle here, I'll make it larger in case you can't see. So it's the top middle one. Crystal size. This part you should know from lab and or the reading you did yesterday. The longer the time of cooling, the larger the crystal. Nothing of these three boxes that we just did today are already, none of these are new to you. This is all stuff you've already heard between lab and the reading we did yesterday. We're going to now get into the new stuff. So top right now. Top right bubble, I'll make it bigger. It is pointing to the word texture. And because this is earth science and because things can't be simple, texture does not mean how it feels. So it's not that smooth, that's fuzzy, or that's bumpy. Texture refers to the size of the crystals. So you should be writing all four of these in the top right bubble. And what I'll This is nothing you have to memorize because as you can see, it is right there where the bubble is pointing to. It's pointing to texture. And it tells you that glassy, it does say non-crystalline. Hopefully you understand that means no crystals. It tells you that fine is crystals less than 1 millimeter, coarse 1 to 10, very coarse, bigger than 10 millimeters. So once again, like I said, texture does not mean how it feels, even though that's what you're used to thinking of it. Texture means how big are the crystals. And again, glassy does not mean looks like glass, though they can. So I'm just going to pull up the screen here for a second. So like I said, glassy means no crystals. So this one, which is obsidian. Most of you have probably seen this at one point, and it looks better here in person. Yes, obsidian's on Minecraft. Obsidian does look like glass. It looks like black glass, so like or brown glass, like a bottom of a beer bottle type situation. So this one is easy. But these other two, and I'm hoping they show up a little. That's not going to focus, huh? Well, this one does, though. This one's glassy. See what I'm saying? Does it actually look like glass even a little bit? No, because glassy does not mean looks like glass. It means there's no crystals. So you could search through this and you would not find one little sparkly chip that looks like a crystal at all. This one is not going to come into focus. This one is albino. It's not going to come into focus at all again. But there are no crystals. These black spots that you're seeing are actually holes. Mind if I try, let's give it a whirl. I want to get lights on a remote so I don't have to walk over here. Oh, well, that one turns out pretty good. So again, perfect reason why you can see that glassy does not mean looks like glass. All right, it's a little better, but let's see. Well, that's just too dark. I just need it less colors around. All right, so again, those black things are not crystals, they are holes. I can pass these around too, so at least those of you that are here. These three are glassy. So glassy means no crystals whatsoever. If you have a fine texture means the crystals are 1 millimeter or smaller. Guys, how big is 1 millimeter? It is small. So on your metric ruler, I got to bring this, whoa, my 6-foot long metric ruler. 1 millimeter is one of these little lines. So if you notice, a millimeter is about the tip of a pencil or a pen. So the tip of a pen is about 1 millimeter, close enough for our sake. So when you're looking at a mineral, or I'm sorry, not a mineral, a rock, hopefully this one will show up. So I don't know if you can tell there, but do you see these little tiny sparkles? There's a few sparkles on here. Sorry, that's white out. Okay, now. See these little tiny sparkles? See how they're just about the tip of my pen? This is about 1 millimeter. So these are fine. If you look at this one, see that black dot right there? That's a crystal. Notice it's smaller than the tip of my pen. So basically, if you're holding these and you're like, I think there's crystals, but I can't quite tell, that's when you're going to call them fine texture. They're less than 1 millimeter. Whereas this guy that I showed you before, so coarse is 1 to 10. So again, 1 is the tip of my pen. So you can see that these guys are all, most of them at least, are bigger. This white chunk is 1 crystal. It's way bigger. 10 millimeters is about how fat your pinky is. So from here to here, you can see all of these crystals are smaller than that. Even most diamonds, can you see it? Diamonds would be considered coarse. So they're between the tip of a pen and how fat your pinky is. So diamonds are coarse. If someone saw a diamond that was bigger than a pinky, even if you're not into that type of thing, you'd be like, whoa, that's a big stone. So that's what very coarse would mean. So again, they're all listed there on the reference table, so you don't have to go searching for these. Non-crystalline is glassy. Fine is less than 1 millimeter. Coarse, 1 to 10. Very coarse is 10 millimeters or larger. So again, on your reference table, wait, let me share this. Everything is listed there. So you can, why are we not moving? There we go. So again, if the rock is considered glassy, see how the box lines up perfect with these 4? So obsidian, basaltic glass, scoria, and pumice. They are all non-crystalline. The fine all match up here. The coarse all match up here. And the only very coarse is this pegmatite. There is another box for texture. So we're going clockwise down now. This is the texture continued box. And it has the word vesicular there. Vesicular is in parentheses says gas pockets. So these are basically little tiny gas pockets that have formed, very similar. You guys ever had a pizza crust with a big old air pocket in it? They're the best, aren't they? No, you don't like that? I love when there's that big bubble in the crust. How's that big bubble get there in the pizza crust? I actually don't know if that is the cause of it, but in terms of how does it actually happen? It's an air pocket, and what happens around the air pocket? There's air in the dough, and as the dough was cooking, it cooked and got hard around that air pocket. The same thing happens with these vesicular rocks. The rocks cool so fast that hard rock forms around air bubbles, and you get these rocks that are full of holes, like that one I was showing you. That was pumice. The rest of that side of the reference table is pretty easy. So you can see that this reference table is broken up into about 3 sections. We just talked about the whole top half of this reference table. Now we're going to move to this middle section where color, density, and composition is listed. This is really easy to read. So as you can see here with color, see how it's listed as dark on the right? So it means that the rocks listed on the right half of the chart are dark colored rocks. The rocks listed to the left of the word color, they're light in color. The ones listed in the middle are ones that they're never going to ask you about because they're kind of in the middle. So here's what I want you to write. Color, right equals dark, left equals light. Same deal with density. If you're to the right of the word density, you have a higher density. And if you're to the left of the word density, you're lower. Again, nothing you have to memorize because it's just right there on the reference table. And finally, what's called composition. This one gets a little weird, even though it's still right there on the reference table. If you're to the right of the word composition, you're what's considered mafic, which just means you have a lot of Fe and Mg. Remember that those letters are from the periodic table. You don't have to memorize them this year, but they are on the back page of your reference table. So Fe is iron and Mg is magnesium. If you're to the left of the word composition, that those rocks are felsic. And again, it is right there on the reference table. Felsic, rich in Si and Al, silicon and aluminum, or aluminum and silicon. The only one left, and this one's a little difficult. I'll have you write it first, and then I'll show you what it means. It says the minerals listed below the rock are the minerals that make up the rock. So what this one means, and this one's a little weird. So again, there's the 3 separate sections. We've got the igneous rocks listed up here based on whether they're intrusive, extrusive, and their crystal size. The middle tells us color, density, and composition. This bottom half, guys, take a look at the words inside this box. So look on yours and look at those words. Look at yours on your reference table and look at those words. Do those words look familiar? Hello? On your reference table right here. These were not on the top. There you go. They're all minerals on the back page of your reference table. So you'll see potassium feldspar, quartz, plagioclase feldspar, biotite mica, amphibole, pyroxene, and olivine. Those are all minerals we've already learned about. So these are the minerals you'll find in these rocks. So what I mean is by the minerals below. So see how, let's look at granite. Granite has a box around it. See how there's a box around the word granite? If you line up, like I did here, I kind of highlighted them down. All of these symbols, so we got polka dots, bigger polka dots, stripes, black ones, and different stripes. Those minerals are all found in granite. So anything that's listed below the word is found in that rock. So what do you notice about rhyolite, vesicular rhyolite, granite, and pegmatite, and pretty much the obsidian and pumice? Come on, guys, stay with me. Let's get off our phones and pay attention. I'll start collecting phones if it's going to be a problem. Yeah, somebody else. Granite, rhyolite, vesicular rhyolite, pegmatite, and obsidian and pumice. What do you notice about those and the minerals in them? No, they're not. They're not all extrusive because obsidian, pumice, and rhyolite and vesicular rhyolite are extrusive, but granite and pegmatite are intrusive. They share common minerals. In fact, they have the same minerals. Vesicular rhyolite, rhyolite, granite, and pegmatite are made of the exact same minerals. They all have potassium feldspar, quartz, plagioclase feldspar, biotite, and amphibole in them. So then what makes a piece of granite different than a piece of rhyolite? Nope, not the amounts. Nope, not the internal arrangement. Those are minerals. We're over minerals. The texture, what do you mean? The crystals are different sizes. Everything in them is the same. Everything in all of these are the same. The only thing that makes them different is how those crystals look. If you have one that's very coarse, it's pegmatite. Just coarse, granite. Fine is going to be rhyolite. Vesicular, fine and vesicular is going to be vesicular rhyolite. The only thing that makes them different is the size of their crystals. All right, so your homework will be, let's attempt page 18, questions 1 through 12. So the homework again is page 18, just questions 1 through 12. You will need your reference table to complete that.